Thank you for the forecasting for such a good initiative. And of course, thank you to all of you. I hope you enjoy this workshop and find it useful for your work. As Harsha mentioned, I'm a senior forecaster at Nixtla. Nixtla is a startup working on time series forecasting. We have created several Python libraries such as stat forecast, ML forecast, neural forecast, the hierarchical forecast, and TimeGPT, the first foundation model for time series. I'm the developer of the nixtlar package. There is an R package used to interface with TimeGPT. And previously, I was a senior forecaster at a consulting company in Mexico City called Peter Dragon. There, I had the opportunity of forecasting for large retailers. This consulting company worked with several large retailers in Mexico City of different kinds. A pet shop, an office supply store, a clothing store, a pharmaceutical wholesaler, and well, there I learned a lot about forecasting. And well, I'm hoping that in this workshop I'll share some of my experiences with you. I'm also a MIT MicroMasters in Supply Chain Management credential holder. I got my credential just last December. It's a very rigorous program, but I think it's a great one, and it really gives you an overview of what supply chain is, not just demand forecasting, but the whole process from demand planning, demand forecasting, inventory management and optimization, and of course, transportation problems related to supply chain. And well, I've been a forecasting enthusiast since 2019. And well, the program for today is we're going to have two parts. The first part, we're going to give an overview of foundation models, how they work, why they're able to generate accurate predictions on unseen data. And then I'm going to talk about TimeGPT, the first foundation model, and the nixtlar package that, as I mentioned, is used to interact with TimeGPT. And in the second part, well, we're going to do an example with a retail dataset. I'm going to show you how you can forecast using TimeGPT via Nixtlar. And I'm also going to share some best practices for retail forecasting that, in my experience, are very important and have really helped me get better results. And well, all the code and slides using this workshop is going to be uploaded to this repo. It's going to be set to public once it's done. And if you want to try TimeGPT for free, please just create an account here. As attendees of this workshop, you can request free access. As a matter of fact, we have a free plan, but if you attended this workshop, you can get additional credits if you need so. We will very happy for you to try TimeGPT with our own data. So let's get started. So let's first give an overview of foundation models. The main reference for this section is an upcoming book by Marco Peixero. It's called Time Series Forecasting Using Foundation Models, and it's going to be released later this year. Although you can already preview several chapters, including the sections we're gonna discuss in this workshop. What are foundation models? In the context of time series forecasting, a foundation model is a machine learning model that has been trained on a very large data set and that is capable of predicting series not seen during training. And some foundation models, in addition to generating point and probabilistic forecasts, are also capable of doing other time series related tasks, such as anomaly detection or time series classification. And there's two big categories of foundation models. The ones that have been specifically designed to handle time series data, obviously TimeGPT, but there's been many more since TimeGPT was released, such as Llama, Chromos, TimesFM. And the other category are large language models that have been extended to handle time series problems, such as TimesLM or Promcast. We're going to focus on the first category, that is TimeGPT, and it was designed specifically for time series. TimeGPT cannot be used for any other task, any prediction task. It is used to generate point and probabilistic forecast for anomaly detection, and it includes several features that we'll discuss in this workshop. And well, why do foundation models work? Foundation models are trained on very large amounts of data. These models often weigh many gigabytes and train for days. And the training requires a lot of computing resources. And the idea is that a single foundation model can predict series with different properties, such as frequencies, trends, or seasonal periods. Even though these series have never seen your data, they have seen, the foundation models have seen other series that are similar enough. And through a process called transfer learning, they're going to be able to generalize to your particular forecasting task. And this is an important, a very important characteristic. A foundation model is going to be able to predict any type of series, be it monthly, daily, hourly, series that have very clearly defined seasonal periods, let's say due to a promotion or some holiday, and series that may have any kind of trend or cycle, say series that correspond to products that are becoming more popular and are being sold more often, or the opposite, which will be products that are now in decline and they're not selling that well. And well, foundation models can also be fine-tuned, meaning that certain parts of the model are trained on your specific data. In this process, only a subset of the model's parameters is updated rather than the entire model, since full retraining will take very long. I think this is an important concept that I think is worth mentioning and explaining, because when people talk about fine-tuning a foundation model, they think, oh, it's going to be trained it's going to be retrained on my data. And that is not entirely accurate. As I said, only a subset of the model parameters is updated. And yes, the goal is to try to fit it to your specific use case. But obviously, in doing so, we also don't want to spend all the time and all the computing resources that were used originally to train the model. And well, just as to make definitions clear, the zero-shot version is the foundation model in the original state. So you basically pass the data, and the model will generate predictions. In the example that we're gonna work with, we're gonna see how to do fine tuning, which parameters in TimeGPT can be adjusted, and why do they represent. And we're also gonna talk about overfitting, because, well, this is a very common problem when you're doing forecasting. Fine tuning is, I mean, well, the whole fine tuning is trying to improve the accuracy of your predictions, but obviously it can also happen that you are overfitting on your validation sets, and maybe once you use it on unseen data, the results may not be that great. So there's an important balance between fine tuning and preventing overfitting. And well, before we go to the example, and now that we're talking about how foundation models work, let's give an introduction to transformers. Most foundation models, including TimeGPT, are built on the transformer architecture. And well, here's a simple diagram, but that it summarizes how the process works. First, the time series data goes through an embedding layer. Here you have your series. It goes here. And in the embedding layer, the series are transformed into a format that the model can understand. Then there's also positional encoding that is added to the data to ensure that the model recognizes the order of the time steps. This is because transformers don't inherently process sequences. Next, the series enters the encoder, where the self-attention mechanisms learn patterns and dependencies across different time steps. And finally, the decoder generates predictions one step at a time. This means that each predicted value is fed back into the model until the full forecast horizon is covered. And well, this is a very high-level explanation of the transformer architecture. It's basically these 4 steps. So let's go into a little bit more detail for each. As I said, the raw time series data requires some preprocessing. The embedding layer converts the data into tokens, which can be individual values or small windows of values. And the model learns an embedding, which is an abstract numerical representation of the time series. And this embedding is going to be very important to capture the patterns and the characteristics of our series. The positional encoding, as I said, is added so that the model understands time order, and it uses a combination of sine and cosine functions to encode position. And well, a good metaphor is how clock hands represent time at different granularities. And then, if you remember the diagram at the beginning, then we move to the encoder. That is a stack of layers, each containing a self-attention mechanism that helps identify the relationships between different time points, and a feed-forward neural network that helps process and refine the representation. So actually, the encoder at the same time is not just this block; it's a combination of different components. The self-attention is very important because it's what helps the model learn dependencies within the time series, such as trends and seasonality. And the this is what allows the model to focus on different patterns in the data, and they can be specialized. One may identify trend, and another may identify the seasonality. And well, from the encoder, we move to the decoder. That again is not just one block; is made of different components, and here's where the predictions are gonna be made. The decoder is, I mean, generally it has different components, such as a mask multi-headed attention layer, a feed-forward network, and a normalization layer. So the decoder generates predictions by using the learned embeddings and feeding them through the architecture. And well, once after passing through the decoder, predictions are made. From here it goes to linear projection. This is where the predictions are generated, and then this is an autoregressive process, in the sense that the first prediction is used to inform the next one. So these four components of transformers, the embedding layers, the positional encoding, the encoder, and the decoder are the key components of a transformer. Some foundation models may use only one or the other, but in the case of TimeGPT, well, we're going to see that it uses both. And now, talking about the advantages and disadvantages of foundation models, as we're going to see, especially TimeGPT, foundation models require minimal code and forecasting expertise. I mean, at least in the case of TimeGPT, can generate forecasts even with few observations, and are applicable to many forecasting scenarios. Again, the idea is that since the model has been trained on such a large data set, is going to be able to generalize to your particular use case. And even though it hasn't been trained on your particular data, it has learned patterns that are very similar to yours, and is going to be able to generalize from that. Of course, they're not a solution for all cases. Your specific use case may not be well represented. That is something that only through experimentation is gonna be able. It's something that only through experimentation you're gonna be able to see. Obviously, well, there's no direct access to the model parameters, and it's kind of like a black box model. TimeGPT currently has SHAP values that can be used to explain the feature, the contributions of each feature, but they still remain somewhat a black box model. I mean, especially when you compare it to models such as exponential smoothing, that there is very clear what the parameters represent. You know, it's a weighted. It's a model that weights the past observations and then generates a prediction. No? And well, in the case of TimeGPT, obviously the server is almost all the time functioning, but of course it's possible to encounter some kind of outage. And although this site, status.nixtlar.io, will always show the current status of the TimeGPT server. So, well, now let's talk about TimeGPT specifically. TimeGPT was the first foundation model for time series forecasting. It was released by Azul Garza, Christian Chalu, and Max Mergenthaler on May 2024. That's the date the TimeGPT paper was released on archive. And then TimeGPT was officially presented in San Francisco a few months later, around July. And well, currently there's a Python SDK, there's an R package, and for users there's a whole dashboard. So you can interact with TimeGPT, and you can you can also be aware of how you've been using TimeGPT. So well, TimeGPT is a generative pre-trained transformer built on the transformer architecture described in the previous section. It is generative because it is trained to take an input sequence and generate an output sequence in an autoregressive manner, so that each predicted element is fed back into the model to generate the next step. And additionally, it has been pre-trained on a very large dataset. We'll discuss this in more detail later, but well, that's what the GPT in TimeGPT stands for, generative pre-trained transformer. Some people have wondered if TimeGPT is related to the famous ChatGPT. The answer obviously is no. It's because of its architecture. But yeah, maybe a downside of this model is that at the beginning people thought it was just an application of ChatGPT. And as I mentioned in the beginning, no, it is not a large language model that has been adapted to handle time series forecasting task. It is a model that from the beginning it was designed to handle this type of data and to generate predictions, detect anomalies, and everything related to time series only. So, well, you probably now recognize this diagram. Is the one we described earlier. Obviously, the decoder and the encoder and the decoder have multiple layers, but the general process is the one we saw in the previous section. TimeGPT has been trained on a huge data set, and then it can be used to generate accurate predictions on data not seen during the training. The formal objective of TimeGPT, that is a probabilistic model, is to estimate the following conditional distribution. That these are the future values of the series over the horizon, given the past and current values, assuming we are at time t. TimeGPT can also work with exogenous features, and the task that TimeGPT is trying to solve is to estimate this function given the training data. This is a little more formal definition, but it is important because TimeGPT is probabilistic in the sense that it's trying to estimate this conditional distribution. And well, as I just said, we have the target variable. We can also have additional variables that are related to this target. We can also have events, either we can have events as binary variables, say the days that we have a promotion, or there's a holiday, and things that can have an impact on the target variable. And well, after going through this transformer architecture, is going to be able to generate a point and probabilistic forecast. So let's talk a little bit more about the TimeGPT training data. As I said, is huge. It comes from multiple industries and domains. We saw in the image, there's data obviously from retail, and this data includes not just product sales, but maybe product inventory, um, and it can have it can come from different types of retailers, maybe a pet shop or or a clothing store, um, of any type. And the dataset also includes series with different scales, lengths, and temporal patterns. So there's hourly data, there's monthly data, there's quarterly data. There's even series that correspond to observations taken by seconds. Obviously, there's many domains, not just retail, but economics, finance, healthcare, Internet of Things, weather, and well, to our knowledge, this is one of the, if not the largest data sets with over 100 billion data points. Um, it is important to mention that there's been minimal pre-processing. Only missing values were interpolated using a proprietary method, but that's it. The data was added with as basically as it was, So it has seen outliers. It has seen series that are very noisy, maybe that have a lot of intermittency, and well, as I mentioned before, this was very computationally intensive. The training took several days on a cluster of NVIDIA GPUs. But well, eventually it was ready. No? So TimeGPT has several capabilities. We're gonna go into more detail of each of them, but initially, TimeGPT was only available through Nixtla, the Python SDK. And for us, the R community is very important. The R community has also a very strong ecosystem for time series forecasting. And that's why we decided to create the nixtlar package. It has been available on CRAN since I think October of last year. We have had 2 releases and even 2 hex stickers. There's also a development version, obviously, on GitHub that has the latest features, but we have tried to make it in a way that the CRAN and the GitHub version are not very different. However, since the Python SDK is constantly being updated and its new features are being added, that's why the GitHub version of Nixtlar may not be exactly the same as the CRAN version. However, we do try to keep them well as close as possible. And well, I really like this picture that I think represents Nixtla. As I said at the beginning, Nixtla has several Python libraries that are very well known and used. The stats forecast, the ML forecast, the neural forecast, the hierarchical. And well, Nixtla is kind of like the odd one out, but still a very important part of the Nixtlaverse and of the Nixtla family. And we with Nixtlar we're trying to expand the already
matcha. Yeah.
oh sorry oh, yeah, we're gonna have we're gonna have a section for questions. So if you have a question, please leave it at the end or write it in the chat. Um, so yeah, as I was saying, Nixtlar is trying to work on this already ecosystem, and is trying to complement what the tools that our users already have. Here are some of them. There is not a very comprehensive list, but in our we already have a very diverse ecosystem of not just foundation models, but of many different types of forecasting models. Um, Obviously, I think anyone that has been working for a little bit on forecasting may know the forecastar package or the Fable package. I'm also a big fan of Model Time that was developed by Matt Dancho and the the business science team. This is a whole framework, not just for time series forecasting, but also for time series analysis. And well, I think Matt is a great instructor. I also had an opportunity to take his time series course, and I learned a lot. I took it a few years ago when I was getting started in this field, and as I said, I learned a lot from him. And the smooth package is also one that I really like, especially because it has an implementation of a complex exponential smoothing. There is a statistical method that is also available in Stats Forecast. And I also really like the Forec data package. It has several implementations of the data model. Sadly, I don't think they have a hex logo, but as I said, R has a very strong ecosystem for time series forecasting. And well, to my knowledge, the only package for foundation models is Nixtla. I hope that changes soon, but well, at least Nixtla is available with this type of models. I mean, obviously you can always use reticulate to interact with Python via R, but Nixtla was really designed with the R user in mind, and in the background, what it's gonna be doing is calling the TimeGPT API, but everything else is being designed with the ARC workshops in mind. So well, now let's go to an example with real data sets. I'm gonna be using the data from the BN1 forecasting competition. That's a competition that ran last year from September to October. It was organized by Nicolas Vandeput on the Data Source AI platform, and it was sponsored by Fliver, Subchains, and Syrup. Nicolas is a very well-known person in the forecasting field. He's the author of several books. I recommend a few of them at the end of this session, and he's very knowledgeable on time series forecasting, especially for supply chain. And well, in this competition, there was a retail data set with over 15,000 time series and a forecast horizon of 13 weeks. The competition had two phases. Phase zero, phase zero only used the data from that phase, and then participants were able to generate predictions for the next phase, which will be phase one, and then they could get feedback on the accuracy of their models. The evaluation metric used was this is basically a quotient of the absolute errors and the errors. And once phase zero was over, then participants had to generate predictions for the next phase, which will correspond to phase two, and then they didn't have any type of feedback. They just had to generate the predictions, and at the end of the competition, a winner was announced. So in this section, I will explain how to use Nixtlar. We're going to see how to set up your API key. That is the first step to be able to generate predictions. Then we're going to talk about the data requirements for TimeGPT and some pre-processing steps that we did for the BN1 competition. We're going to go into more details on how to use TimeGPT and how to leverage its features that are available in Nixtlar. And along the way, I'll share stories from my experience as a retail forecaster to give you some insights and practical tips. And well, I mean, after several years as a retail forecaster, I have a lot of stories that hopefully will help you in your own work, and or at least will prevent you from making the same mistakes that I did. So first, let's go to R. Let's go to R. Right now, you should be seeing R Studio. Let me just maybe increase the size. So, well, in this example, we're gonna use the tidyverse and data table. The tidyverse, as many of you know, is a very famous R package. Basically, the default in any R script to handle the data. And that table is going to be used in the background to be able to load the data sets. As I already mentioned, you can use the CRAN version of Nixtla, or you can use the development version. Right now, I'm gonna use the current Nixtla version that actually corresponds to version 0.6.4. And I'm also going to load this script that contains several functions. I'm going to go into more detail in a minute. But basically, these are just functions that are going to be used throughout the example. These are not functions from Nixtlar. They're just here for this particular use case to do some specific tasks. And again, all of this is gonna be available after the workshop in the repo. So, well, the first step is loading the data. As I explained, there's two data sets from phase 0 and phase 1, and The phase two is the one that corresponds to the actual values. These are the values that the contestants had to predict. So we're gonna use them solely for evaluating our results. And well, here we're using one of those functions that it's in the function script. What this function is doing is just basically loading the data and then merging the IDs of each series. This dataset contains three different IDs: the client, the warehouse, and the product. And TimeGPT, when working with multiple series, it needs a unique ID. We cannot pass all these three columns. We need to convert them to one unique ID. And let me already load the data. And well, this how it looks. As I said, there's a unique ID, there's a timestamp, and then there's the target column that in this competition it corresponds to product sales. This is a good moment to explain the requirements of TimeGPT. It means these three columns. It doesn't have to have these specific names, but if you have names that are different, then you're gonna need to specify them. The ID column is this one, the time column is this one, and the target column is, well, whatever name you have. The time column is very important. It has to be in this format, either as a string or as date type, and it's very important to be in this format: the year, month, date, and hour, minute, and second. I personally prefer to use as POSIT instead of as date, because I've seen that sometimes as date makes, if you have date, let's say 2025 02/14, and you have it at midnight, sometimes this part is going to be removed. And there's actually an issue that someone opened in Nixtlar. So in the code, there's already a way of preventing an issue with this format that as they sometimes just converts to this. So that's why I'm using this function. But in theory, as date is also supported. So, well, this particular data set, as we saw early on, has 15,053 series. There's 183 different weeks. The earliest date is on July 2020, and the last date in the training data is going to be, well, the first week of 2024. So we roughly have four years of data here. And Nixtlar has a function called Nixtla client plot. It's gonna you can use it to visualize the data that in any forecasting task should be the first step. And here we can see some interesting behaviors. I mean, for example, this series had a huge increase at the end of 2023. This series clearly correspond to products that are now obsolete. I mean, there's been no sales since 2022. And well, here's another example of a product that clearly is no longer being sold, and as we can see, there's many different patterns that we're going to try to capture with TimeGPT. The Nixtla client plot function is always going to generate eight series randomly, unless you specify the IDs that you want to plot. And well, in this particular case, I think that the visualization is very clear, but there's an additional argument, the max in sample length, if you only want to forecast, let's say, the last 100 observations. And well, there's an R package that I particularly like. It's called the Telescope R package. I think this is a great package, and it's very easy to use, and it allows you to generate this trellis display, and you have a lot of flexibility on the number of rows and columns, and I think this is a great tool to visualize all data set. Obviously, we're not going to be inspecting all the time series, but this R package allows you to create different filters. I only have a unique ID here, but maybe you can also add sales, and then you can check out the top sellers, or if you have more information about these unique IDs, you can filter by unique ID. Maybe check the series that corresponds to a category, and you can have a better idea of the forecasting problem that you're facing. To generate that display, you just need to use the Telescope package. This code is also going to be available, but again, just with a few lines of code, you can generate this display. So, well, next we're gonna evaluate the top 5 competition solutions. These are the results of the winning submissions. The PN1 competition evaluation is again a function in here, and it's basically an implementation of the metric we saw before. That is, the quotient between all the absolute errors and the error. So in the competition, well, these are the results, and with this we can now start working with TimeGPT. The first step is to set up your API key. If you don't have one, you can go to dashboard.nixtla.io and you can get yours, and there's a pre-planned, so you can start experimenting with TimeGPT. And as I said, as attendees of this workshop, we can also give you additional credits for you to not just replicate this experiment, this particular use case, but also try it on your own data. And let's go back for a minute to this presentation. Setting up there's different ways of setting up your API key. There's an unsecure and a more secure way. Nixtlar has a Nixtla client setup function. So you simply call this function, you pass your API key to it, and then you're all set. The downside is that, well, anyone can see your API key that is used to identify you. So that's why it's not very secure. Another way of setting up your API key that is a little bit more secure is placing it in your environment, either through options or using the use this library. So if we go back, we can use this, and then you just need to place your API key here. I mean, this is gonna open my environment, and you can place it there. And well, keep in mind that this is gonna be a use. I mean, this is a more permanent method compared to the Nixtla client setup function. I mean, once the RStudio session is closed, your API key is no longer gonna be valid. I mean, in the next session, you're gonna need to set up again if you use the Nixtla client setup function. If, on the other hand, you place it in your R environment, then next time is already gonna be there. And there's also an nixtlar function to validate your API key. And this function is simply going to return true or false, depending on whether your API key is valid or not. This function is just for convenience. I mean, you can see the status of your API keys in your dashboard, but you can just check it directly in R. This is not something that you need to do every time you generate a TimeGPT forecast, only when you want to check for the first time if the key is valid. And well, now we're ready to use TimeGPT. We're gonna first use the vanilla TimeGPT. This version is the standard. We are simply passing the train dataset and the forecast horizon, which in the competition was 13 weeks. And you may see here a warning saying that the model that the horizon exceeds the model horizon, and this is an internal requirement of TimeGPT. Each frequency has a specified horizon. This doesn't mean that you cannot generate more than certain steps. It's simply that just for the model and that particular frequency, that may be too many steps in the future. But later we're gonna see that there's a long horizon model designed to work better on long horizons. And we can again use the Nixtla client plot function with the train dataset and the forecast we just generated. And let me resize this. So well, here it is, the TimeGPT forecast. Oh, this is not it. Sorry, is it? No? So here it is, the TimeGPT vanilla version. And well, using the competition, using the same evaluation metric as in the competition, we get that TimeGPT places third. And I mean, I think this is a result that shows how in this particular case, TimeGPT out of the box, the zero-shot version, does a very good job. And the next version of TimeGPT we're gonna try is the long horizon model. This model is just a particular version of TimeGPT that has been developed for longer horizons. As I said, it really depends on the frequency of the data. For example, for daily, it's 7 days. For monthly is 12 months. For quarterly is, well, for quarters. And you can check out the documentation and see which horizon corresponds to your data frequency. And if your forecast horizon exceeds that, then we recommend using the TimeGPT long horizon model. Again, as always, we can evaluate we can see the forecast using the Nixtla client plot function, and the long horizon model actually does better than the TimeGPT vanilla, and it places second. So we're already off to a very good start. Let's see if we can continue improving this model. And the competition has also included exogenous variables. In particular, it included prices. And well, I think it's a good example of why plotting our data is very important, because, well, you can see the prices over here, and this, I mean, there are some series that didn't have any information, and for some others, the price information has these gaps, has this weird behavior. So right off the bat, we know that maybe the information provided by the prices may not be very reliable. But let's try TimeGPT using the prices. And well, here again, I'm using the read and prepare data. It's gonna do the same as it did before, and we're also gonna do some pre-processing because TimeGPT cannot have missing values. This is a very important data requirement, but sadly we cannot. It currently cannot handle missing values. So we're gonna do the same as before. We are gonna do some pre-processing, and well, we're also gonna remove the gaps in the series. This is the pre-processing I was talking about. We're going to use interpolation to fill out gaps, and for series that have no information whatsoever, we're just going to set price equal to 1. TimeGPT, well, TimeGPT could use a series with exogenous variables and series without them, but then we will have to forecast them separately. So for convenience, we're just gonna set a price equal to 1. Obviously, it's not gonna provide any meaningful information, but it will allow us to just work with all the series in the same code. And this is an important distinction. Is a new feature in nixtlar. Previously, if you wanted to use exogenous variables, then you also needed to know its future values. However, in one of the latest versions of TimeGPT, this requirement was relaxed. And now there's a distinction between historic and future exogenous. And there's this parameter, hist exolist, that is a vector. Maybe the name is kind of unfortunate because in Python it is a list, but but in R, well, it's a vector with the names of the variables. And in this case, we are assuming that we don't know the future values of price. They were not provided for phase two of the competition. So we're just simply gonna pass them as a historic exogenous variable. And well, while it's running, let me tell you also about the future exogenous. Um, in this case, it's an additional parameter. The data set here includes the target variable and the historical exogenous. And then in this other parameter, XDF, we're gonna pass the future prices. That in this particular example will be forecasted using TimeGPT. So there it is. And well, it actually improves by very little, but now this model is in second place. And well, now we can move to the future exogenous. Since the competition didn't provide them to the participants, well, we can use TimeGPT to generate their future values, and as I was explaining before, we can just pass them. So once we have the results, we actually can see that it doesn't perform that well as the model using just the historical prices. And if we think about this, it makes a lot of sense. I mean, we're already making a lot of assumptions on the prices. We're interpolating. We are setting the price to one for the cases where they don't this information is not available. So yeah, I mean, we are using TimeGPT to predict them, but then we are passing that prediction, and obviously the assumptions may not hold, and well, that's why the result is not good as the one with just the historical information. But this is I think this is a very important feature available in Nixtla, and it gives you the opportunity to make this distinction between historical exogenous variables and future historical exogenous variables. In my experience working in retail, I think this is an important distinction, because things like holidays or promotions are usually known in advance. I mean, if you're working with holidays such as Valentine's Day, well, we all know that it's going to be on the same day every year. But maybe we have another variable, such as prices, that is not really well known at the time of making the forecast. So with this feature of Nixtlar, we can set prices as the historical exogenous, which is what we did, and then we could add let's say promotions as as an exogenous variable that is both historic and future. And well, just let me go back. Let me just give you a cautionary tale. In my experience, people may think that the exogenous variables are gonna improve the forecast. We've clearly we've seen that in for the competition, they did by a little, just the historic, but be mindful of the exogenous variables that you are passing. I actually have two interesting stories from my time working in retail. So let me tell you about them. And the first one was a forecast I was working on for a chain of pet shops. We actually had a very accurate forecast, and then they were able to give us the prices. And well, we were expecting to see an improvement in the forecast by using this information. But then I mean, after inspecting the data, which again should always be one of the first steps in any when making any forecast, we realize it has like a very weird behavior. I mean, sometimes it increases and then decrease, and well, this a pet shop that I've gone to, and I knew from experience that prices didn't change that much. And then upon closer this, I mean, inspection and with discussions with the client, we realized we hadn't given the real prices. I mean, they were giving us the quotient between the total amount that they have sold that, I mean, the total amount in money that they had gotten in that week divided by the number of units sold. And that clearly is not the price. And that number was being modified by discounts that some clients has and by unaccounted promotions. So that's why the prices have had these sudden changes. And for that particular case, it didn't help the forecast. It actually made it worse. And another good story I have is about some clothing stores. Um, Again, it's a chain of stores. They have, I don't know, like 100 stores in Mexico, and we generated a forecast for them. It was generally okay. I mean, it had good accuracy, but then there was a week where the accuracy was way off. And but I mean, sales were going through the roof, and obviously the forecast hadn't been able to capture that. And again, talking with the client, it turned out that they had implemented some never before seen promotions because they were trying to try to increase their sales because they all the stores were forced to close during COVID. So, I mean, these two stories, and you then so you can be careful when using exogenous variables. And I think they also illustrate another important point, that is to have very good communication with your clients. So if you are generating the forecast for your own business, well, be mindful of the information that you are passing to the forecast, because it may not help at all, or it can even make the forecast worse. So, well, after talking about exogenous variables, let's talk a little bit about fine tuning. There's three important parameters in Nixtla related to fine tuning. The first one is the number of fine-tune steps, that is the number of training iterations applied to the input, minimizing the forecasting error. The second is fine-tune depth, that is an integer value from 1 to 5, indicating the set of parameters that will be fine-tuned. When set to 1, only a small set of parameters is adjusted, and when set to 5, all of them are. There's no way of controlling what parameters are tuned. I mean, this is done internally by TimeGPT, but this parameter can help us well can help add another layer to the fine tuning. And finally, the last important parameter regarding fine tuning is the fine tune loss. That is the loss function used during fine tuning. By default, it uses a proprietary loss function that is close to outliers, but we also have these other functions available: the mean absolute error, the root mean square error, or the mean absolute percentage error. So these five are available. At the moment, there's no way of passing a custom function. It has to be one of these five or the default. And an important mention is that fine-tune dev would only work when fine-tune steps is greater than 0. If you set fine-tune steps equal to 0 and then try to select fine-tune dev equal to whatever number, then nothing is gonna happen. No fine-tuning is gonna be done. So let's go back to our example. Now, fine-tuning requires a minimum of observations. If I know that I mentioned as one of the advantages of foundation models that it can generate predictions for series with few observations. And yes, that is true, as we saw before. But when you want to do some fine tuning or generate prediction intervals, as we're gonna see later, then you do need to set a minimum of observations. So this is very straightforward to implement in TimeGPT. Here, the separate series is another of the helper functions, and the only thing that is gonna do is separate the series that have at least this number of observations. It is important to make sure that these two sets add up to the original one and that no information is missing. So with the series that have enough observations, we're gonna use 200 fine-tune steps, a fine-tune depth of 4, and we're gonna keep the fine-tune loss to the default. And since we had good results using price as an historical exogenous variable, well, let's keep it that way. I'm sure you're wondering where those numbers came up, and I'm gonna explain that in a second. And well, for the series that are very short, we're just gonna take the forecast with exogenous variables that we already generated. And well, the results are here. To be honest, it's not that great. It's actually worse than the model with the future exogenous variables. And maybe you're wondering why this is happening. I mean, I thought fine tuning was supposed to train TimeGPT on my data, and yes, that is happening. It's just that for this particular case, well, it didn't help, and this is an important consideration. Fine tuning is I mean, we expect fine tuning to help improve the forecast, but that is not guaranteed. And this is something that you need to experiment with, because, well, you cannot know it for sure. I mean, hopefully fine tuning improves the forecast, but as I said, it's not guaranteed. And this leads me to something called the auto time GPT. And this is not a function of Nixtla, but is a function that is very easy to set. And it basically creates a search space for the fine-tune steps, the fine-tune depth, and the fine-tune loss. So as you can see, I mean, the code is going to be available in the repo, but what this is doing is generating multiple TimeGPT models. and then computing the score. This takes, I mean, I've already made some tests, and well, from all these tests, the best result that I sorry the best result that I got was like for for a fine-tune depth of 4 and 200 fine-tune steps. And I think this is an interesting case because we can see how it then seems to overfit, and is what I was mentioning in part one of the workshop. It is important to be careful with fine tuning because then it can overfit. So well, it seems that, I mean, in this particular case, fine tuning didn't help, but it helped us showcase these very three important parameters, and also led us to showing this auto time GPT. Then again, as I said, it's just generating multiple time GPT models on a search space. We're actually thinking of implementing this function in the Python and obviously in the R SDK, but still in development. But in the meantime, you can use this code and this idea to try different fine-tune parameters and figure out if fine-tuning helps your particular use case, and if so, well, which number of steps, depth, and fine-tune loss is best. And well, I'm gonna go a little bit faster since I think we're a little bit running out of time. But well, TimeGPT is a probabilistic model, and it can generate probabilistic forecast. In the background, I mean, is using conformal prediction. That is a framework for creating distribution-free uncertainty intervals for predictive models. And again, it's very easy to use. We simply define the confidence level, let's say 80% and 95%. We pass it as an argument, and value between 0 and 100, not inclusive, is valid. And the nixtlar plot function will also automatically recognize the prediction intervals. And well, quantiles are also available. Quantiles represent the cumulative proportion of the forecast distribution. Here, any number between 0 and 1 is valid. And as before, the nixtlar plot function is automatically gonna plot the quantiles. And finally, I want to show you that TimeGPT can also be easily used to detect anomalies. TimeGPT is basically generating a forecast for the historical data and then creating prediction intervals. So any observation that falls outside those intervals is flagged as an anomaly. The output is going to tell you which observations are considered an anomaly using this criteria, and the plot function can also plot the anomalies simply by saying the plot anomalies argument equal to true. I'm sorry, Ali. Oh, there it is. Obviously, since there's no really a lot of information on on the data set. I mean, all the series, we know they correspond to retail information, but the competition didn't provide any context. I mean, what type of products they are, what industry, I mean, in the retail field they belong to. I mean, it could be anything. So well, it's very easy to use, but in this particular case, well, maybe it's not that straightforward to evaluate, because I mean, it's kind of context dependent. And there's two important features available in Nixtlar that I didn't use in this example, but you can check out the vignettes to learn more about them. First is the cross-validation method that is a robust method for evaluating forecasts. And then the historic forecast that is a function in Nixtlar, is the Nixtla client historic, is going to generate fitted values, meaning forecast for the past observation. This is actually a difference between the Python and the R SDK. In Python, there's no function just to generate the historical forecast, but in Nixtlar there is. So again, if you want to learn more about it, you can check out the vignette. And let me go back to the just to summarize after this example. I think today's takeaways is that foundation models are a new tool for time series forecasting. They may or may not be the best fit for all your series, but they're worth experimenting with. Forecasting is not an end in itself, decision making is. So my recommendation is that don't focus just on KPIs and think about how your forecasts impact the decisions you make. And well, retail forecasting comes with challenges like handling a large number of series, dealing with intermittency, and this is more on the personal side, but working within tight time constraints. And I think it's very important to mention that it requires a good mix of technical skills and business knowledge. Just think about those two stories I told you about, the pet shop and the clothing store. And I think it really showcased that you can have a very sophisticated model, but if you don't have good information or you don't have domain knowledge, then disaster can happen. And well, TimeGPT offers strong performance compared to other forecasting methods. It's relatively easy to implement. So my recommendation is just to get started, experiment, and keep iterating. We saw in the use case that for that particular case, fine tuning didn't work very well, but maybe for your use case, it does. And well, in the example, I show you how to use Nixtlar to visualize your data. That I already said this before, but should always be your first step. How to implement TimeGPT, what you need to do to set up your API key, and what are the data requirements. Build long horizon forecast with TimeGPT. Fine-tune your models with those three parameters that we discussed, the steps, the depth, and the loss. And also try different TimeGPT models via the Auto TimeGPT. As I mentioned, this is going to be an upcoming feature. But in the meantime, you can easily implement them. I mean, it's just check out the code, and you can see it's very straightforward. And well, we also saw how to incorporate exogenous variables, both historic and future. There's an important distinction. And we also saw how to generate probabilistic forecasts to have a better sense of uncertainty. Maybe in this case, again, there's a lot of intermittency in the data, so they're very noisy per se, but with just the level parameter or the quantile parameter, you can get probabilistic forecast. And something that I forgot to mention is that you can generate prediction intervals or quantiles, but not both. I mean, if you need both for whatever reason, then you need to make two different TimeGPT codes. You cannot do level or quantile because that will generate an error. And finally, we saw how to detect anomalies. And as I mentioned, the cross-validation and the historical forecast are also available in Nixtlar. And just before finishing, I want to share the resources. This is the Nixtlar official documentation. Please give it a star on GitHub. This is the Nixtla documentation. And for the first part, this is the book that we use. It's a great book. Marco is my co-worker at Nixtla, and this is gonna be released, I think, summer of this year. There's also a podcast with Azul Garza and Monolito Goswami. This is the Forecasting Impact podcast. That is the official podcast of the IAF, and for which I volunteer. So if you want to learn more about foundation models, well, check out the episode. And about forecasting and supply chain, I also recommend these two sources, the LOCAT blog. LOCAT is a French company working on supply chain. They've been champions of probabilistic forecasting, and the blog has a lot of great resources. And I also recommend this book by Nicolas Van de Putte. As I said, was the organizer of the PN1 forecasting competition. This book was released just a few years, the Man Forecasting Best Practices, and it's a great book that talks about how to incorporate this technical knowledge and the business domain. I mean, because as I said, you can have a very sophisticated model, but if you don't consider those business requirements, then the whole forecasting project may fail. So it's important to be mindful of these best practices. And I mean, I think I don't mind. I mean, this was supposed to last an hour and a half, but I don't mind staying a little bit more. We can move to a Q&A if there's some questions.
I think questions on the chat now.
Let me check the chat. Then, to be honest, I don't know what's can TimeGPT run locally? No. There's an enterprise plan, and then I mean, if you get the enterprise plan, we can discuss. We can discuss you hosting it, but in the free plan, no, it's not possible to run TimeGPT locally. And okay, next question. With the long horizon model, what is the limit before hallucinations? Well, it really depends. I mean, I know that the horizon is usually, usually a business requirement. I have had to generate forecasts for like a complete year, which obviously the further you go, the less accurate it becomes. But yeah, I mean, I think it's important to mention that the long horizon was designed to try to reduce this, but obviously is a hard problem, and even with the long horizon, I mean, at the end, well, that may not be very reliable. Can you work with a customer that has lots of data that can be used to improve your model? Yeah. I don't know if I understand that question fully. But yeah, I mean, here we had a data set with 1,553 products, but TimeGPT has also been used in the M5 competition, for example, that has, I think, had twice as much. So yeah, we can handle many time series. And the Air Passenger series is well known. Yeah, I mean, I agree that I think we all use the Air Passengers data sets because it's so easily recognized. Okay, and sorry, I got to properly test it with your own data, we need to know the most recent date in the data used to train TimeGPT. Where can we find that information? TimeGPT, as I said, was released in 2024. It's just I mean, it has so many series. I think Joanna was the one who wrote this question. Please write to us, and we'll try to provide more concrete information. Hopefully that will help your personal use case. And just before ending, let me give you a little bit of a spoiler. We're working on a TimeGPT 1.5 version. I'm not sure when it's gonna be released, but it's already in the works, and hopefully that will be even better.
I have two quick questions. So
Okay.
in Nixtla or in TimeGPT, we can extract both the prediction intervals and the quantiles. Can we also generate the sample future paths? Let's say like 500 future paths or 1,000 future paths, just to mimic the actual distribution.
Just to mimic, no, I mean, at least not directly. I mean, you could try to generate different TimeGPT models, but that will require slightly different data sets. I mean, I'm thinking that maybe you can tweak it a little bit just to try to simulate different paths, but no, out of the box, you can just generate the prediction intervals. And I mean, I only use 80 and 95%, but you can use any number between 0 and 100. I mean, you can potentially use 10, I mean, in intervals of 10 or intervals of 20.
Okay, thank you. Do you have any more questions? It seems no. Thank you very much for accepting our invitation. I know this is really early for you. Thank you for taking the time to be here today. And it was really interesting presentation. And it also gave me the theoretical understanding of how TimeGPT works and how other foundation time series are working. And thank you very much again for giving your time for us today.
Thank you to everyone that attended. Don't forget to get your free TimeGPT trial, and thank you, Harsha, again for the invitation, and the one who's thankful for the opportunity.
Yeah, thank you very much. So we can wind the session today. Take care all.